There it is. Okay. So, you guys have cut these out. I haven't cut mine out yet because can't be bothered, to be honest. But I will help you guys get started on this. I'm just trying to move this dang wire out of the way. There we go. All right. The way I would tackle it, so I'm not telling you what 4 groups I want these in. I want you to see patterns and try to recognize it. It does relate to stuff you did last year. So hopefully when you see it, it'll click. Now, some things to note to help you kind of figure out how to group them together is to look where the arrows are. So the arrows tell us reactants and products. So before the arrow is our reactants. After the arrow are our products. So that would be the first thing I'm looking at with all these equations. The other thing with these equations is I provided both the word and the symbolic equation. So up here is word. That one's symbolic. The reason why I provided both is because it's useful to see both. Yes? Huh? Is it? Yes, it is. Thank you for trying to help me, though. Thanks. Oh, Cindy, before you run off, grab you what we need to do today. We are working on this worksheet. You need to cut it up, and we're trying to categorize them into 4 groups. That's toughest. All right. So, yeah, word, symbolic, reactants, products. The other thing you will notice that I've put on here are the states of matter. So S, what do we think that is? What are the 3 states of matter? Solid, liquid, gas. So S would be solid. G would be gas. G would be gas. What else am I looking for? If you have an L, what's that? Liquid. If you have an AQ, what's that? Aqueous. It dissolves in water, so it's soluble in water. All right. So when you're trying to get these into 4 categories, most of them will have just a pair. A couple of them will have 3 because we have 5. So we can't evenly divide 10 by 4. What I would suggest you do to help you get started is have a look at the number of reactants and products, and then also look at states and things like that. The other thing to think about would be, do I have an element? Do I have a compound? Those sort of stuff. Do you guys remember element and compound, or should I recap that? Recap? Okay. So element is something that is from the periodic table and a pure substance. So sodium is sodium. Chlorine is just the chlorine element. Even though there's a 2 here, and we have 2 chlorine atoms, because they are the same atom, it is still an element. Compounds are 2 or more that are chemically joined together. So this here is a compound. 2 or more. Different is the key word here. Elements. Chemically is the other key word. I'm not going to write in capitals because that annoys me. Joined together. Want me to zoom up? Are we good so far? So those are the things I would look for. So on this side, I have 1, 2 for my reactants. On my product side, I have only 1. If I go to the next one down, I see that there's 1, 2. I can see it over here also. 1, 2. There are 2 reactants. In this case, there are 2 products. So do you think these 2 belong in the same group? Probably not. I also see that there's element, element, compound. I see compound, 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 compound. All right? So human nature, it's all about pattern recognition. I want you guys to figure out the pattern. There are, like I said, 4 groups. There'll be 2 groups with 2, so basically a pair, and then 2 groups of 3. Give it a go. All right. The good news is that it looks like pretty much everyone has gotten the right groups, which is good news. That's the first step. It's also a really important kind of like scientific kind of skill set to look for those patterns. It's also just human nature. We look for patterns. The funny thing is, it was actually organized before you guys cut it all up. Yeah, sorry. It's just easier for me to then write my notes. So this one here, you have 2 reactants, 1 product. This one over here, we see 2 reactants, 1 product. Now, if we think back to last year, when we have things coming together, actually, there's one more there. The last one was the calcium oxide and water. Again, 2 reactants, 1 product. So all of those orange ones are synthesis reaction. It's one word that it's called. The other word that's been called is combination reaction. So I'll circle this in orange. So the orange ones that I've written down, those are your combination reactions. You might also hear it being called synthesis because you synthesize something. So that's the first category. So what we're looking for that is basically 2, maybe more, different reactants coming together and making 1 product. All right, the next one, I'm just going to change colors. If we look at it, we notice we have 2 reactants, 2 products, 1, 2 reactants, 2 products, 2 and 2. What else? Now, the problem with that one is that we can't just use the 2 reactants and 2 products as the deciding factor. Because if we go lower down on our list, we should hopefully notice that this one over here has 2 reactants, 2 products, 2 reactants, 2 products. This last one over here, again, 2 reactants, 2 products. So we can't just use the number as our classifying condition. We now need to look for more information because I said there's 4 groups. So the thing I wanted you guys to pick out in this case was looking at the states. So in this one, we see we have aqueous, aqueous. One of them is solid, aqueous. This one over here, aqueous, aqueous. One of them is solid, aqueous. This one on the bottom, we're starting with a solid, an aqueous, and a gas. This one here, a solid, an aqueous, and a solid. And this last one on the bottom is aqueous, 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 solid. So what I'm seeing here specifically is that I am mixing ionic solutions in these 3 examples with the purple. So the purple examples, we see ionic solutions. So basically a salt that's been dissolved into water. And then after I mix those 2 things together, what I notice is I'm producing a solid. That solid is known as our precipitate. It's raining out. Does this ring a bell? So we then call these precipitation reactions. The other word that you guys might have heard from last year, I think, is double displacement. There are, like, double displacement is the umbrella term, and precipitate is a specific type of double displacement. So precipitation reactions are the ones that we are kind of focusing on. So I'm going to call it precipitation. Our internal is going to focus on this reaction. Okay? Keep going. All right. So I'll go through what the red one is, and then we can go back into the middle. So this one we have 2 and 2. We have 2 and 2. The thing I wanted you to notice with this one is that we had one of these things as an element, and then the second thing was a compound. And what has happened is this element here has replaced the hydrogen. And so now we have magnesium chloride and we have hydrogen being released. This one over here, we have the zinc and it's pushed out the copper, making zinc sulfate and copper being released. So this is your single displacement. We will talk about some of those reactions with a single displacement when we go into redox. All right. Are we good so far? Ready for the last one? Oh, I want to do a different color. Not like a blue. All right. This last one here, we notice we start with one reactant. We have two products, one reactant, two products. So what we notice is something is breaking down. We think of the word decomposing. So this is a decomposition reaction. And those were the 4 types of reactions you guys learned last year with your chemical reactions internal. You learned it at the beginning of the year, so this time last year you did this stuff. So no surprises that it was rusty and you couldn't remember some of those words. But like I said, the main thing I wanted us to kind of recognize with this is the precipitation reaction is going to be the focus. And the other thing to recognize is just getting ourselves used to seeing chemical equations again. Getting us used to understanding reactants and products, getting us used to seeing symbols in the symbolic equation and balancing them. All right? So now that you have these organized, you can glue them in. Or if you don't want to bother gluing them in, you can snap a photo of it, whichever works for you. I will scan this and I will put it online, so you can also print this out later if you want. Cool? All right. I'll just pause the recording and get us set up for the next activity. All right. So, next thing we are doing today as our activity is something that I like to call vocab detective. Very similar to what you guys have just done. I'm going to write a list of examples. It's going to be a much shorter list because we type the size of 5 things. And I only need to categorize them into 2 groups. So a lot easier than this first test. When you group them into these 2 groups, you will be able to find our mystery vocabulary words. There's 2 vocabulary words that I want you guys to try to figure out. So you just get a piece of paper and let me write down our words. All right. So our first word that I am writing down is going to be flour. The next word I'm going to be writing down is sugar. Then I'm going to write down sand. Then I'm going to write down, what's another one? Oil. And the last thing I'm going to write down is salt. Those are my 5 words. And what I want you to do is group them into 2 groups. One group will have 2, one group will have 3. Oh, that's probably too generous to tell you that. Whoops. And from those groups, you'll be able to figure out 2 vocabulary words, hopefully. Give it a go. All right. So first off, what's my first group? Soluble. Which 2 things are soluble? And then the other 3 are insoluble. So, nice way to recap and learn our vocabulary. So we're talking about solubility in this case. Really important because when we're talking about precipitation reactions, a solid is forming and that solid is not soluble, which is why it's formed. So let's kind of recap some vocabulary words just because I'm mindful you guys will probably need to know them. Let me get a different color. I want more colors in my life. All right. So when we have, say, a solid compound, Say, for example, salt, NaCl. I mix it into my beaker, and that has water, H2O. Yep. There are two terms that we use for how we describe the water and how we describe the salt. Who remembers them? They both start with S, which is very inconvenient. Salt. That's a good guess. Solute and solvent. So we mix the solute into the solvent, and it dissolves. So it disappears, and when we have that reaction occur, what we're going to get then is a beaker with little salt particles mixed around. So what we can now write is NaClAq, because the AQ tells us it's aqueous and it's been dissolved. Yep, lots of chemistry language. We refer to this thing now as a solution. So that's why I was saying when you're looking at those reactions, we had a precipitation reaction. You're mixing two solutions together, and then we're seeing what happens when we do that. What else did I want to add? The way I remember solute and solvent is solute, I think it's soluting, and then it jumps into the water. And solvent is venting at the solute to hurry up and dissolve. That's the way I remember it. I hope that helps you guys. All right, I'm trying to think what other words we need to know. The other words you guys need to know is concentrated and dilute. Those two words should hopefully be a little bit more familiar. So if I have a concentrated solution, I'm trying to draw it so we can see it. So concentrated means we have a lot of solute in the solvent. Yeah, think about it like you're drinking cordial, like straight cordial from the bottle, disgusting. Dilute means that it doesn't have a lot of the solute and the salt in the solvent. So you're often told to dilute things down so that way it doesn't taste super strong. If anyone's trying to be really budget, they might like water down their like sports drinks so that way it goes a little further and stuff like that. And you can taste it, so it doesn't taste as strong. So yeah, I think those are the words that I wanted to cover for today, for that lot. We end at 50, I believe. So you guys have been doing great today. You have two choices. I think I talked to you guys about it. You either have 5 minutes of preferred activity time, you guys can have some free time basically, or we keep working and you save that time for the bank and you can collect it so that way you can have longer break times. So what would you guys like to do? Would you like your 5 minutes of free time now, or do you want to save it for later and try to get like a period off? Save it? I heard save it. Anybody else want to? Is the vote for save? All right, cool. So what I'll do is I'll put a Quizlet up with the vocabulary that we've talked about. Sound like a good plan? All right.